All right, hello. This is WipingBot. This is an optimization-based surface wiping approach in Drake. I'm Willie.
And I'm Nishanth. So to start off, we want to convince you that wiping is both an interesting and useful manipulation problem. It's interesting because it involves constantly reasoning about maintaining force against the surface, and also because of the planning problem of which order to wipe various dirt locations in. Wiping is also very useful because it's among the top requested services by users of robots and a very important component of cleaning. Okay, so let's start off by talking about our simulation setup. For actually wiping in this project, we choose to weld a sponge directly to our EWA. To simulate dirt, we leverage Drake's Mesh Painter functionality, which lets us update the texture of one object when it comes into contact with another object, namely our sponge. Now, we were only able to do this for our dirt on our table, and so dirt on our plates still has a simple particle-based representation. Okay, so now that we have the simulation set up, let's talk about actuating the robot. For wiping, in addition to a simple IK-based position controller, what we need is a hybrid force position controller. Our first attempt at designing this, we did a PD controller on X, Y, and Z and output 0 torque on RPY. But this didn't work for seemingly obvious reasons in hindsight. So we decided to implement a PD controller on roll, pitch, and yaw. However, while this did better, it still didn't work because of the circular difference property of angles. So this makes a naive P controller on RPY bad. So we settled for a simple D controller on RPY, and this produces a great trajectory that keeps constant force contact with the table, just like we need for wiping.
Now that we have a hybrid force position controller, we need to generate a trajectory for our wiping motion. We took 4 different approaches for generating this trajectory, ranging from a naive approach to where we assume that the dirt locations is just our trajectory. So we'll go from dirt location 1 to 2 to 3 to 4 to so on and so forth. But as you can see, this may lead to unintelligent behavior with respect to the displacement of the robot. So we also formulated this problem via constraint optimization problem, which tries to minimize the displacement of the robot while also satisfying strict constraints and threshold constraints with respect to the dirt location. Now that we have a simulation, a hybrid force position controller, and a wiping trajectory that we want to move along the table, we can now talk about our overall control strategy. How it works is from initial configuration of a gripper, it moves to a location on the table using pure position control. When it's at that location, it then switches into our hybrid force position controller, which moves along our wiping trajectory that is given by our optimizer, while maintaining a force in the Z direction that is weak enough to allow for moving along the XY direction, while also strong enough to make sure that our plate doesn't move when we're doing the wiping motion. To conclude the project, we set up a simulation in PyDrake in order to simulate the table, the plate, the gripper, and the dirt. We also made a controller that uses pure position control for navigating and hybrid position control for wiping. And we generated trajectories via different optimization approaches for our controller. And then finally, we evaluated our trajectories on a set of experiments.